The soil profile. This is not the place to go into a long discussion of all the characteristics of individual soils. I shall be content to say that every soil has a number of natural properties, of which the following are important for purposes of recognition and characterisation. A. Geological history of the mineral part of the soil. B. Topography of the soil. It is characteristic of it, individually, that either it lies on a steep hillside, or forms part of a level expanse, or has some intermediate slope between the two extremes. C. Its own peculiarities of natural drainage. D. Its chemical characteristics from acid to alkaline. E. Its soil profile. The last mentioned term is a technical one, and about it something more must now be said. The soil profile is the view of a soil which we obtain on the wall of a pit which we specifically dug. We see the same thing when excavations are made for roads or buildings. Quite often, but not always, when we look at a soil in this way, we may find such a spectacular differentiation of the soil into layers, or to be more accurate, horizons, that a child could see them at once. I shall speak of one such case. The succession is as follows. 1. On the surface there is a layer of pine needles, mixed with the leaves and small twigs of a variety of trees. This litter is about 2 inches deep. 2. Below this forest debris is a thickness of 8 inches of well-decayed plant debris, humus, incorporated with loamy sand. Owing to the presence of the humus, the soil is very dark brown, almost black. 3. The next 10 inches is ashy grey loamy sand. This horizon is most spectacular, and looks as though somebody has deposited a layer of grey sand 10 inches deep. But this is not so, and, as we shall see later, its origin is entirely natural. 4. Below the ashy grey soil is a horizon of 4 inches of compact, dark chocolate brown sandy loam, succeeded by 5 inches of sandy loam, mottled rusty brown and pale brown. This horizon is succeeded by 6, the rock, which is a pale yellow, lightly consolidated sandstone. To the experienced eye, this soil profile tells an unmistakable story, and, since it is typical of the processes which characterise many soils in the British Isles, it will be no waste of time and space if we now consider its implications in a little detail. These implications are important for the archaeologist. 1. The surface layer is formed of the fallen leaves and other plant debris which gradually decay and become incorporated with the mineral matter to form the sort of material which characterises 2. The next horizon below. Here the sand grains which were originally, when part of the rock, yellowish-brown, have been bleached because humus is acid, and has a solvent action upon the iron compounds which form the colouring matter, and, often, also the cement of the sandstone rock. There is a great deal of decayed organic matter, and it gives this part of the soil a very dark tinge. Rainwater is constantly, and, what is very important, slowly, passing down through these horizons of the soil. The rainwater carries down with it acid and humus. For hundreds of years this process has been going on, and it has evidently removed all the colouring matter originally present in the upper part of the soil. The colouring matter, in this case, was the brown hydrated ferric oxide generally called limonite. This is fairly easily removed downwards by acid soil waters, to be redeposited in a lower horizon. The very ashy grey horizon, 3, has by this washing out, leaching process lost all its colouring matter. But in the next 2 horizons, 4, the chocolate brown, and 5, the mottled brown and pale brown horizons, that colouring matter has been reassembled to give there different intensities of colour, reinforcing the iron compounds already present in the parent sandstone. Here the sand grains, instead of being bleached, are more thickly coated with limonite and similar materials than those of ordinary sandstone. These are horizons of accumulation. It may now, I think, be readily appreciated that if we dig trenches into sandy soils in which the process of alluviation, depletion or impoverishment, and illuviation, accumulation or enrichment has taken place, we have to be very careful that we do not mistake the horizons produced by natural processes of soil formation, pedogenesis, with layers of material deposited by our ancestors when they moved the soil in their construction work. Most soils in which a very marked profile has been developed as a result of the downward passage of acid-laden water through the uppermost layers are very ancient, and it has been suggested that their formation has taken thousands of years. The materials in which the most spectacular profiles are to be seen in Great Britain are the lightest sandstones and pebble beds, through which the water can pass rapidly after every rainstorm unless the land is very low-lying. These sandstones are also materials in which there is no lime, to neutralise the effects of the acids which form in the surface layer of the soil from the decay of leaves and other plant debris. Sandstones are widespread in Britain. They are, of course, indicated in geological memoirs and bulletins and on geological maps, and these important publications of the Geological Survey should be consulted by every interested archaeologist. It must, however, be emphasised that geological surveys are generally concerned with the rocks below the soil, and this, of course, is not the same thing as the soil itself. In materials like clay, I mean real clay, not merely heavy soil, the soil-forming processes are naturally hindered, because there is no rapid downward movement of water in the soil, and no passage through the clay itself at all. There is a soil profile, but it might be passed unnoticed. Between clay rock and sandstone there are many intermediates. In some of these a very obvious soil profile has been developed. In others, it is not so noticeable. In new sand dunes, newly deposited river muds, and on seashores, there has not yet been time for soil profiles to develop, and so little differentiation can be seen. Such materials are called skeleton soils. I have noticed some horizonation, produced since disturbance, in soil that has been moved a few years previously by excavators on a Roman site, and I see no reason to believe that a very great lapse of years is really necessary before horizonation may begin to show itself in skeleton soils. All excavators of chalk and other limy soils should know something about the special circumstances which have attended the formation of these soils. They are, generally speaking, thin soils, and all are formed from rock which consists very largely of calcium carbonate. Chalk is an earthy limestone. Limestone soils in the British Isles nearly always contain enough fragments of rock right up to the surface to neutralise the acid production by decaying vegetation immediately it is formed. There is consequently no acid available to bring about changes deeper down in the ground, such as we have already seen producing very spectacular soil profiles in sandy situations. The soil profile over limestone, including chalk, frequently exhibits about 5 inches of soil containing fragments of the rock. The 5 inches rest immediately upon the limestone rock itself, which often has its upper layers fissured and fragmentary. Such soils are called rendzinas. It must, however, be remembered that chalk rock and other limestones are quite frequently covered by deeper materials which have either been transported from far or near to their present situation by ice, water, or wind, or else have been derived from the insoluble residuum of the original rock, which generally consists of a reddish clayey deposit, sometimes called terra rosa. A well-known example of such a material is clay with flints, a superficial geological deposit which has a fairly widespread occurrence over the chalk formation in the part of England never covered by a moving ice sheet during the glacial period. That is to say, south of a line from Bristol to London. When soils are waterlogged, as usually happens with riverside meadow soils, there is a shallow top horizon, say about 8 inches deep, typically dark coloured and rich in organic debris. Below this is a lighter coloured horizon, often several feet deep, and frequently showing a prismatic structure, i.e., this horizon then consists of lumps of similar shape, which can be pulled out if there has been dry weather. These lumps are about 4 inches wide, 2 inches thick, and about 12 inches high, but tapering away both at the top and bottom. In this horizon, especially towards its lower part, small black concretions, mainly of hydrated ferric oxide, occur, typically in sizes ranging from that of a wheat grain to that of a hazelnut. Below the prismatic horizon is the permanently waterlogged part of the soil. It contains a good deal of plant debris, and since air cannot penetrate from above, it is generally oxygen hungry, and contains blue iron compounds which give it a bluish-grey tinge. Such a layer is called a gley. The word rhymes with clay, horizon. There is no doubt that when a gley horizon has occurred in an archaeological excavation, it has sometimes been mistaken for a man-made layer. It seems that some so-called ritual floors, blue materials associated with prehistoric burials, are of this nature. The kinds of soils frequent in Great Britain are summarised on page 49, in the key, figure 18a.